JAMB candidates, welcome to graphical interpretation, okay, under distance and velocity. So we are going to look at distance time graph and also velocity time graph. So we are taking distance time graph first, okay. So if you need any assistance, you need any material for your last minute preparation, okay, this is my WhatsApp number, okay. If you need mentorship, send me a message on WhatsApp. Let me help you. Okay. All right. So this one is what distance time graph. What does distance time graph mean? It means what? Distance plotted against time. So we are trying to look at the distance covered with time. All right. That's it. That's the motive of the graph. All right. So distance usually on the what? On the y-axis. Y time usually on the what? X-axis. So interpreting this graph is very easy. It's very easy. So first of all, we have to find the slope of the graph. At 0 points, at the mark 0, see 0 here, at mark 0, speed is equal to 0. Velocity is equal to 0 at this 0 mark or at the point of rest. This one is what? Point of rest. Okay, point of rest. Okay, everything is equal to 0 at this point of rest. Know that. So the next is the slope, or also called gradient. All right, the slope, or also what? Gradient. Okay, so slope or gradient. All right, so this slope, where do we have this slope? Okay, is the speed. Okay, so the slope is equal to speed. So all the speed, all this constant speed here, this one is also another speed. All these are slopes. Okay, so slope is equal to speed. Slope is equal to speed. This one here is slope. This one here is slope. Here is what? Constant velocity. Okay, but we are talking, because we are talking about distance here, that's why you are not seeing constant velocity here. But here, this straight line here means constant velocity. Okay, so just know that the slope is equal to the speed, and the speed is equal to the slope. So all this slope here, all this slope, they are known as speed in a distance time graph. All right, so the next is the straight line, which is this straight line is equal to what? Constant speed. Okay, it means that the speed is constant. This place you have a straight line, okay, that is no slope, horizontal, equal to what? Constant speed. So straight line is equal to constant speed. Okay, constant speed, like speed Darlington. All right, so the curved line is known as what? Acceleration or changing speed. All this curved line, like here now, from here, this curve here like this, or this total curve like this, is known as what? Is known as acceleration or changing speed. All right, so the curved line, so the area under this curve, okay, this curved area is acceleration. Okay, so area under each curve, all this area like this, acceleration. So area under curve is equal to acceleration. Okay, so that's that for that. So that's all about the distance time graph. Let's look at velocity time graph next. This is a velocity time graph. All right, so velocity on the y-axis plotted against time. Okay, so we are looking at the velocity, that's the change of rate of displacement attained with time, or at every particular time. Okay, it's easy to interpret, very easy. All right, so the first we are going to be looking at here is the what? The slope, which is also known as the gradient. All right, so slope or gradient, okay, is equal to what? The slope is equal to the acceleration. Okay, acceleration. That's why the slope of the velocity time graph is known as what? Acceleration. Okay, since slope is equal to acceleration, what next are we looking at? We are looking at the types of slope. We have two types of slope. We have the positive slope and the negative slope. Positive slope means that it's climbing. Negative slope means that it's descending. So here now shows that it's climbing, it's ascending. Okay, here it shows that it's what? Is descending. It's trying to come to rest. It's descending. Okay, so this one now, speeding up or ascending. Speeding up. Speeding up. This speed, acceleration speed, is equal to what? The positive slope. Okay, while speeding down or decelerating, okay, or slowing down. Okay, slowing down, because you don't slow down with speed. That's why we can't use speeding down. Okay, so slowing down or, you know, deceleration. Deceleration is also known as what? Is equal to what? Is equal to the negative slope. Take note too. All right, so we have to look at the flat part or the horizontal part. Look at it here. Remember, in a distance time graph, this straight horizontal part, flat part, is known as what? Constant speed. But here it is called what? Constant velocity. Okay, so horizontal or flat part is equal to what? Constant velocity. And in this constant velocity, when the velocity is constant, at constant velocity, acceleration, which is s, is equal to 0. Acceleration is equal to 0 at constant velocity. Okay? So, at constant velocity, acceleration is equal to 0. Take note of that. Alright? Then the final one is the area under the curve. And this area under the curve is known as what? Displacement, or total distance covered. This area under curve is equal to what? Displacement. Displacement or what? Total distance covered. So this area under this curve here like this, all this area here, from here to here, is the what? The total distance or the displacement. You know the definition of displacement now. The distance moved in a specific direction. That is displacement. Is a what? Is a vector quantity. That's it for velocity time graph. Let's look at the next lesson. Let's look at projectile motion. Projectile motion. Okay. Okay. So projectile motion, quickly. Projectile motion is a kind of motion of an object. It's a kind of movement of an object. Okay. When the object is fired into space with changing angular velocity. When there is changes, a kind of movement that an object exhibits when it's fired into space as a result of changing angular velocity. All right. So let's take this for an angle, for example. Let's say this is an angle, for example. Okay, this is an angle, for example. All right. And we have our what? Our acceleration due to gravity. Okay, which is what? Let's say 9.8 meter per second squared. All right. So this one is our acceleration due to gravity. And remember that gravity acts on any object that is in the earth. Okay. Gravity acts on any object that is in the earth. All right. So remember, this is our what? Our angular velocity, like Nyash. Okay. Anytime you think of angular velocity, remember Nyash. Okay. This is our angular velocity. As a result, projectile motion occurs as a result of change, which is delta angular velocity. Okay. Change in angular velocity. That's how it occurs. So when you fire an object to space, for example, this one is Ronaldo. He kicks this ball from the ground to space. That space is air. Space. Fire this ball to the air, and you can see this ball. This ball goes up. Because of the force applied by Ronaldo, number 7. Okay, the ball goes up. Because that force that Ronaldo applied to this ball is greater than this acceleration due to gravity, the ball continue going up. The ball continue what? Accelerating. It continues to accelerate. When it gets to the point that the force applied to this ball, the velocity at which it moves, okay, is not equal to acceleration due to gravity, 9.8 meter per second square, is at this point, okay, no acceleration. So when it gets to the maximum height, here, no more acceleration. It's not equal to what? The acceleration due to what? Gravity. Okay, at what? Maximum height, 9.8 meter per second square, or 10 meter per second square. Okay, acceleration due to gravity. Okay, so at this point, you see, so at the maximum height, because the force applied to the ball brought about a velocity that is greater than the acceleration due to gravity, the object continues accelerating, gradually accelerating. And remember, it was an applied force, and as that force is applied, the force is not constantly applied. Okay, so as the object or the ball continues to accelerate, it's going to be losing force, and as the force reduces, the acceleration reduces. So that's how the acceleration continues to reduce until it attains its maximum height. And that maximum height is the point at which the acceleration of the ball or the object fired into space is equal to the acceleration due to gravity here. So there, you are going to notice no more acceleration. You see? No more acceleration there again. So because the force is decreasing very swiftly, it's decreasing so fast. The force applied on the ball, because it's not a constant force. This force applied on this object is decreasing so fast. It gets to a point at this maximum height, the acceleration due to gravity will now be greater than the velocity that force can provide. And because the acceleration due to gravity is greater than what? The velocity of this object fired into space, what now happens? The object starts to what? Decelerate. The gravitational pull of the earth starts acting on the object, and the object is what? Pulled down. Can you see? The object that continues to fall. The more greater the acceleration due to gravity is as compared to the velocity of this object at this point, the greater it is, the more the ball decelerates. As the force reduces, the velocity of the ball reduces. This one, acceleration due to gravity overpowers it, pull it down until eventually come to what? Rest. Okay, this one is also rest. Okay, and at rest, acceleration s is equal to 0. S is equal to 0. Can you see? So you see this object that was fired into space, that did something like this, is called projectile. Projectile. Okay, this object is called what? Projectile. Projectile. Okay, then you can see this part, this curved part that was created by this projectile. Okay, is called what? Projectile motion. Okay, this part, this motion here, this circular motion here, you know, by the what? By the ball, okay, or by the projectile is called what? Projectile motion. All right, as easy as that. So this projectile motion occurred as a result of what? Change in angular velocity. What is angular velocity? Angular velocity is a velocity at an angle. Okay, so I told you that imagine this as an angle. Maximum height here is one angle. Bring it down. Okay, from here again, look at it. This one again. Here, another right angle triangle again. Okay, so here is what? Angle 90. Here is what? Angle 92. Okay, so the total 90 plus 90 is 180. You can see that this ball or this projectile has what? Has run or covered 180 degrees. All right, it has what? Covered 180 degrees. Okay, for what? Normal triangle. But the first one, we are looking at the first one. Let's say when the object is here, is what? At angle 45 degree. This is what? Angular velocity, 45 degree. Can you see? It was here before. At what? Let's say the ball was here. Okay, at what? 30 degree. Okay, you can see at 30 degree. You can see that at this point now here is now what? 90 degree. Okay, 90 degree. Okay, you can see that this part was formed, or this projectile motion was formed because of the change in angular velocity. Here it was 30. Here it turned 45. Here it turned 90. Here it turned back to 45. Here it turned back to what? 30. And here 0, rest. Can you see? Because of the change, as a result of the change in what? Angular velocity. As easy as that, chicken. Huh? So what are the applications of projectile? I already taught this before, but let me just quickly refresh your memory on it. All right? So refreshing your memory on the application of projectile is what? Applied in what? Sports. Sports such as what? Basketball, where you throw ball like this. Football, volleyball, and so on. All the ball, most of the ball, projectile is applied. Also, launching of rockets. Rocket launching. Launching of rockets, and also is applied in what? Gun. Firing a gun. Firing a what? A gun. All right. Which other one again? Which other application again? In many your day-to-day activities. Okay. Anything that involves throwing an object to space and that object is having a curved motion is what? Is projectile. Okay. It's projectile. You see projectile, or you see projectile motion every day. Every day in our everyday life. So that's it for projectile motion. All right. I will see you in the next lesson.